We're going to go ahead and begin. Thank you everyone for joining. For some, it may be lunch for you. For me, I'm in Hawaii, so it's about 6 o'clock here. So wherever you are dialing in from, we truly appreciate you joining us today and taking the time. And we have prepared a very highly requested presentation for you all today. So before we begin, I want to go over a few house rules. So number one is recording. We will be sending out this recording after the webinar. So look out for the email in your inbox. In addition, there is a Q&A section. We'll try to answer throughout the presentation, but we will have a section as well at the end. And if we don't get to it, know that we are always available via email, but we'll try to get through as many as we can. Also, at the end of this webinar, we will have a survey. We do appreciate if you can provide your feedback. We always want to improve how these webinars go, topics that you want to learn about. So please fill that out after the event or once you sign out. Lastly, we do have captions enabled. So we do have both English and Spanish speaking in our presentation. And I put in how that looks like here. So at the bottom, you should see a CC. Once you click that, you can choose the language you want to see the captions in. This is only available to those with certain update on Zoom, and if you're on the correct browser or the right computer. So apologies if that does not show up, but it is enabled for those who do have the capability. So yeah, thank you again for joining, and I'm gonna pass along the mic to our two presenters here, Gabby and Wes.
Saludos, buenas tardes. Gabriel Perez Sepúlveda, Gaby. Primero que nada, quiero agradecer a Jan por apoyar con este webinar y también por el feliz día de la mujer en este gran día. Así que de verdad que es un buen día estar aquí y es algo que estamos motivando para también tener más mujeres en la industria. O sea, que hay organizaciones sin fines de lucro como Busque Modelo, y veo que también están en el grupo aquí, en el webinar, Alison Mason, que apoya mucho esa iniciativa. Así que de verdad que es muy importante para nosotros. Mi nombre es Gabriel Pérez otra vez. Vamos a estar presentando varias cositas hoy. Vamos a estar presentando desde soluciones para mitigar riesgos en futuros desastres naturales, o como hemos visto ya aquí en Puerto Rico, que hay cortes de luz o situaciones con energía eléctrica. Así que les vamos a dar varias ideas, varias soluciones que ya hemos implementado anteriormente aquí en Puerto Rico. Y también vamos a estar hablando un poco de fondos y programas que actualmente están disponibles debajo de CDBG MIT. Así que vamos a estar pendientes a eso. Así que nada, yo lo puedo dejar con Wes y después voy a estar yo hablando un poco de varios proyectos que hemos hecho aquí en Puerto Rico y hablando también de los fondos disponibles. Wes. Thank you.
Hello, everybody. Wes Kennedy here, Blue Planet Energy. I'm the technical sales engineer. So I'm the guy with the answers. You'll talk to me with the project opportunities, and I'll help you figure out how to solve the problem. Next slide. So what's our agenda today? We're going to talk a little bit about just who Blue Planet Energy is. And then the bulk of the time that you'll hear me talking will be describing the Blue Planet Energy solution, which is the blue ion system. And we'll talk a little bit, some technical stuff. We'll talk a little bit about different applications, you know, what batteries do to solve problems. And I know there's a wide array of backgrounds on the webinar today, from installers and engineers to people working in nonprofits, people working in the healthcare industry. So if the technical stuff is a little too technical, don't worry about it. The takeaway, I'll just tell you the punchline here now. Blue Planet Energy is the best partner to work with on developing microgrids for community resiliency. So if you don't remember much else from the webinar, just remember Blue Planet Energy. Then we'll come back to Gabby and we'll talk about some projects we've done. And then Gabby will overview all the various funding and aid opportunities that have been unlocked for Puerto Rico and other places. And then we will leave some time for Q&A. If you have questions during the webinar, go ahead and put them into the Q&A box, not the chat box. And we will try to answer them within the flow if it works. If not, we'll try to get it at the end. And then if not, then we'll get it via email after the fact. Okay, next slide. So view here, Hank Rogers. He's the founder of Blue Planet Energy, among many other things. He achieved some fame and fortune with the video game Tetris. And right after he had made it onto Easy Street, he had a life-threatening heart attack. And in that kind of moment of clarity, he realized that he had not completed his life's mission. And the mission is to rid the world of the use of carbon-based fuels. So a big mission, but it's one that we're all aligned with. Started Blue Planet Energy to be the commercial arm of various research projects that he had been part of, finding the best energy storage battery for stationary applications. So started Blue Planet Energy in 2015, and we've been after it all along. So the company mission here, you can see, it's about making individuals, families, businesses, communities, country, and the world safer, more resilient with battery energy storage microgrid systems. So it's kind of a mouthful, but this is where we're headed. Next slide. So Blue Planet Energy, we have a host of products, but the core is our battery technology. Now we're going to spend some time talking about what makes our batteries different. But the company as a whole, we're not just selling batteries. We do software for monitoring and control. We, of course, have the battery that we'll get into the details, but the thing to remember, it's the best performance in the industry. It's a full 15-year, 8,000 cycles. You're going to hear that many times during my presentation because we really want you guys to understand that not all batteries are the same. And what would a battery be if it was unsafe? Not one that we would want in our homes or businesses. So our battery is fire safe. We're fully scalable. So from small, off-grid cottage in the mountains up to large scale campuses, hospitals, resorts, those kinds of opportunities. And we put a lot of thought into the way that we bundle the battery to make it easy and safe for the installer. And we think they look quite good too. Next slide. Okay, so here's where we will get a little bit into techno geekery, but these are really important numbers to understand to really realize that not all batteries are created equal. So what we have here is we're comparing 4 different battery chemistries. So lead acid, which is kind of the grandfather of energy storage. It's been around for decades. We have 3 different lithium chemistries. 2 are common in the automotive space and also in some of the kind of self-contained, packaged, all-in-one systems that you can see in the market. NCA, which is nickel, cobalt, aluminum oxide, and NMC, which is nickel manganese cobalt oxide. These are used by some of the names you may have heard, companies like LG Chem, like Samsung, like Tesla. This is the common chemistry there. And then on the far right, we have our Blue Planet Energy lithium iron phosphate, or lithium ferrous phosphate, or LFP for short. So there's kind of what we're looking at. Then we have different characteristics of the batteries that we like to compare. So the first is the cycle count, the useful life of the battery. This is kind of the main metric when you purchase your battery. And lead acid is pretty poor, from hundreds of cycles to maybe 1,500 cycles before they're done and need to be recycled. NCA and NMC, much better than lead acid, at somewhere between 1,000 and 4,000 cycles. And then we have the blue ion LFP with the industry leading warranted 8,000 cycles. So double or more what other lithium chemistries offer. Next thing to talk about is efficiency. So how much of that energy that's put into the battery and then taken back out of the battery, how much of that is just lost in the chemical transformation? Lead acid, once again, not super strong in this category, 60 to 70% efficient. You know, that's 30 to 40% loss in storage of the battery. NMC, NCA, much better, in the mid-90s. But once again, the blue ion LFP, industry leading 98%. So almost none of your energy is lost in the storage and discharge. Charge and discharge rate. This is kind of a hard one to wrap your head around, so I'll just be brief. Essentially, it's how much power can be pushed into a battery of a given size. So in lead acid, you can really only trickle charge it. That's a fraction, so C/8. So you can only put about 20 watts into a battery of 100 watts, and you can only pull 20 watts back out. So that's a very low C rate, so the way that we call that. NCA and NMC, since they're really developed and their strength is around electric vehicles, they have high C rates. So you can charge them very quickly and discharge a lot out. So with the blue ion battery, we keep the math very simple. It's a 1C. So as much as the battery capacity is how much you can charge into it and how much you can discharge out of it. So this is a little bit in the geekery level on this slide. So we'll just move on, and well, if it comes up with a question later, we'll talk more about it. Depth of discharge. This is another key element about how much of that battery that you purchased do you get to actually use. With lead acid, you can only use half. If you try to use all of your energy that's stored in your lead acid battery, then it will burn out quickly. And that's how we get those life cycles of 300 or 400 cycles. But with lithium chemistries, it's quite good. The NCA and NMC is typically 90, 95%, somewhere in there. You have to kind of read the fine print of their warranty. But with the blue ion LFP, it's a full 100%. So if you buy 10 kilowatt hours, you get to use 10 kilowatt hours, and you get to use that 10 or 8,000 times. So once again, the best in the industry. Maintenance, energy storage would be nowhere if we were stuck with lead acid. Lead acid microgrids have been built for decades, and the thing that kills those microgrids is the maintenance. Those batteries wear out because they're not taken care of, and you have these investments that were supposed to do useful work that are just sitting unusable. Lithium, all chemistries, very low maintenance. So this is one clear advantage across all of them. Now we get to safety. So as I mentioned earlier, we at Blue Planet Energy, one of our prime directives was not just to have the best performing battery, but we did not want to have an unsafe situation in our homes and in our businesses. So with lead acid, they're made of toxic materials. When they're charged, they off-gas hydrogen, which is flammable. So with lead acid, you've got to deal with that. With NCA and NMC, they have an issue of thermal runaway, which is a very frightening concept. At the chemical level, if the battery starts to get hot, and this can happen from any number of reasons. It could be physically struck by a car in the parking lot. It could be a computer system malfunction where they get overcharged or even over discharged. They'll get to a certain temperature where they start to chemically decompose, liberating oxygen, and cobalt is flammable. So the whole thing can catch fire, and that fire feeds itself, and it's very hard to put out. So at Blue Planet Energy, we don't like that risk in our homes and businesses. And the Blue Ion LFP is a stable chemistry. Even if it's forced into a thermal event, like by a fire in the building where the battery is just a part of it, they still don't go into thermal runaway. They don't liberate oxygen. They don't feed their own fire. And we are also made with plentiful non-toxic materials like iron. And then the last thing to talk about is this whole idea of conflict minerals. So as the world seemingly shrinks, we're becoming more interconnected, it becomes really important to ask, where do the materials that make up my products come from? And both NCA and NMC have cobalt and nickel, both of which are toxic. And the mining industries that have sprung up around cobalt in particular is very poorly regulated. And I'm sure you've seen the stories, but frankly, it's something that Blue Planet Energy didn't want to be a part of. So lithium, iron phosphate, no cobalt, no nickel, safe, non-toxic. Phew, okay, thanks. That's as detailed as we'll get in this deck. Thanks for sticking with me. Safety. So we'll key on a couple of these concepts and break them out a little further. Next slide. So the industry has done a good job of doing testing to determine safety and compatibility. So UL has a testing protocol known as 9540A. Now the thing to know is this is not a pass or fail test. So sometimes people will say, oh, we passed UL 9540A. That's not true. What it is they just, UL runs the batteries through a series of tests, and then we watch and record what happens. So at Blue Planet Energy, we've done at the cell level test, where they abuse the battery, they heat it up and they put a nail through it. And the only thing that happens is the battery swells a little bit and a little bit of smoke comes out, and it's non-toxic. And to be safe, we did then the module level. So the module is the battery that you'll actually physically touch when you're installing. Ours is a big black box. Inside it has all the cells. And so we've done the module level test where they try to get one of the cells to go on fire and then see if it spreads. So that's what propagation is. And with ours, the one cell that they force does its thing, it swells a little bit, it gets black, a little bit of smoke comes out, but even the surrounding cells are very untouched. So we have a very safe module level test. Then unit level is when you take those batteries and put them in the enclosure. So that's this photo you see on the left. and then ultimately the installation level, which would be like in the electrical room or in the shipping container. So because ours is fundamentally safe at the cell and module level, there's no need to do a unit level or an installation level. Whereas other chemistries have to actually put elaborate and expensive fire mitigation, sprinklers and special gases and fans and all this stuff. With the blue ion LFP, we don't have to do this. Next slide. So here's something visually illustrating how important cycle life is. So the blue ion battery, 100% depth of discharge. So you get to use every watt that you paid for 21 years. That's what 8,000 cycles looks like if you were to do it once a day. Other lithium chemistries, they only give you 90% usable for about half as long, 10 years. And then there's old lead acid bringing up the rear of the pack. So fundamentally safe and fireproof, fundamentally reliable. Next slide. Now, as I mentioned very at the beginning, we have two physical products. We call the smaller one the HI. This is a box in the middle. And this is a 48-volt battery. And so 48 volt in our industry historically has coupled well with a whole host of battery inverters. So the inverter is the thing that's going to take the energy out of the battery and do work, and then put energy back into the battery to charge it back up. And so our HI works with any of the big names. Those of us on the call that are in the industry, you'll recognize Solarc and Schneider and Outback and SMA. So we work with all these guys, and with some of them, we've done what's called close coupled communication, which is on a software layer through computer wires, to keep it simple. We communicate directly with the inverter so that the inverter knows what the battery can do, and the battery knows what the inverter wants to do at a very high speed, very efficient methodology. Next slide. Now, with that HI, we can scale that up to pretty large systems. We call it a small, but it can go up to over 400 kilowatt hours. So this is enough to run very large homes or small commercial opportunities, maybe in a hospital. But we realized that in the market, there was a need for something even larger. So we took the tried and true proven chemistry that we built for the HI, and we built it into the LX. And in this LX, we take those batteries and we wire them in such a way to where their voltage gets higher. And with higher voltage, you get better efficiencies, and we can work with bigger inverters and have bigger projects. So the LX is 800 volts on the DC side, fully scalable from 128 kilowatt hours all the way up to 2 megawatt hours. So this gets quite large, and this is where you can do industrial applications, larger factories or larger campuses. Next slide. Oh, and there it is. You can see you can get bigger with them, up to 2 megawatt hours. Okay. So initially spoke about how the battery itself, the cell itself, is inherently safe. But when we decided how to package the batteries, we also kept safety and installability in mind. So what this photo is showing is on the left-hand photo, you can see the top of the enclosure is flipped open. So this is what we call a bento box. And this is where all the communications and the fusing and the low voltage wiring that has to be there to make the battery work are up there in that enclosure. So no lethal voltages to be messed with up in there, and very easy to work on for both the initial installation and ongoing maintenance if any is required. The other photo is if you open the enclosure, you'll see those batteries in there. So, and you'll see this bright orange box. What this is a physical plug that when the batteries are being shipped and when they're being installed, that plug is pulled out. So you'll just see a little socket there. When that plug is pulled out, the battery terminals is 0 volts. So you're just moving inert, safe boxes, and you put them into the enclosures. You do all of your wiring, both for electrical and communications, all of which is included. And then when you've built out the battery enclosure, you put in the battery plugs, and now you have 800 volts, which is a lethal voltage. So we keep safety in mind, not just inherent to the battery chemistry, but even the way we design the product to be used and to be installed. Next slide. And then here's just a quick comparison about how these two products overlay. So at the HI, we can go from as little as 8 kilowatt hours. So that's like a small residential system, all the way up to 448 kilowatt hours. So that's the capacity of the battery. That's like how much energy is stored in the, in the bucket, so to speak. And then power is determined by the inverter. The inverters can be from as small as a single inverter of, say, 6 kilowatts, all the way up to multiple arrays of inverters, up to 144 kilowatts. So a sizable amount of power, once again, well into commercial scale. With the HI, we do either 120, 240 volt, this is your regular residential service, or 208 three-phase. So this is commercial service. The battery voltage, 48 volts, and the controls, so what you can do with the battery is going to depend on which inverter you choose. So most installers have inverter brands that they're comfortable with, that they know about, and they're going to, that kind of inverter ecosystem is going to determine what the Blue Ion HI can do. The LX, not only is it bigger, right? We talked about power from 125 kilowatts up to 1 megawatt, energy from a couple of those enclosures that you see, 64 kilowatt hours, up to 2 megawatt hours. But then the service voltage is three-phase. So 480 natively, but can be stepped down to 208. Battery voltage, 800 volts. But then here's the big differentiator between the two. With the LX, we integrate a control system that can work with solar panels, wind generators, regular generators, gas or diesel generators. It works with where the utility connection comes in, and of course, charges and discharges the battery. So with the LX, it's a more of a hands-on engagement with Blue Planet Energy to build out an entire working microgrid. Next slide. Next slide. So what can you do with batteries? Well, there's 3 major applications that we're going to talk about. First of all, off-grid. So this is the roots of the whole solar and storage industry. People developing properties out away from utilities. And this is where you produce all of your electricity on site. usually has a backup generator in the mix. And then the idea is to use as little of the generator as you can with solar, wind, and micro hydro. And with the microgrid level controllers, we can control all of those different applications, including loads. So when you're off grid and your battery is getting low, it's easier to shed things you don't need than it is to run out of power. But the thing to know is this is off grid, full standalone. A lot of the batteries in this space, a lot of the manufacturers don't like off grid. We love off grid because our battery is so robust that we're going to continue to deliver power day in and day out for decades. Next slide. Now, the opposite of off-grid is grid connected, right? So this is in town. You have the utility grid available. And generally speaking, when you have grid connection with batteries and solar, what you're doing is trying to minimize your electric bill to the utility company, while also providing backup power if the utility fails. Okay, next slide. This self-consumption is a common market application when you're connected to the grid. So sometimes utility companies will say, yes, you can connect your solar system to our grid, but you may not export beyond a certain amount. So here's the arrow showing just a typical grid connected solar system. And if you click it again, grid restriction is where the utility says, we don't want any of your solar energy exported onto our grid. So with batteries and with controls, we can watch the flow of energy at what's called the point of interconnection. So that's the point where your home or your business is connected to the utility company. And we can curtail or reduce those flows so you don't, make the utility company upset. Without batteries, if you did this, you'd be throwing away a bunch of your solar that's overproducing during the middle of the day when your loads are very low. So with these grid self-consumption or zero export or grid restriction systems, you capture your own solar energy and use it within your own home or business, and you don't export to the utility company. Next slide. Now, the other thing people do with storage is called tariff optimization, which is just a fancy word for making your utility rates as low as possible. And they come in two flavors. So one is demand charge management. So this is where you have certain loads in your home or your building that when they turn on, they have a tremendous spike to get going. And then once they get rolling, then they come back down to a more low level. What utilities will do is they'll charge you for how tall the peak is, even though the duration is quite small. So what this chart is showing is kilowatts up the x-axis and time across the y-axis. And you see that the width, the time of these spikes is very low, but the utility will charge a premium because they need to meet those high peaks. With storage, the battery will discharge when the load starts. We do this with software, and will absorb that high peak by just discharging batteries at the same rate at which the load is coming on. So what the utility sees is just this low in this graphic, something around 25 kilowatts instead of 100. And this can have tremendous impact on your bill, right? So let's say the utility says, oh, you're going to pay $3,000 without storage, but with it, you're only going to pay $810. So just as an illustration. But these are just for minutes of load. So these are very small duration of high power loads. Next slide. The other thing is, instead of minutes of super high peak loads, you have just the flow of a load in a building. So this blue line is showing the general shape of the demand curve on the grid. So in the middle of the night, it's very low. And then starting in the morning, it comes up when people get up to get ready for school and get ready for work. And then it stays kind of steady during the middle of the day. And then in the evening, everyone comes home or goes out to restaurants, and you have this peak in the afternoon. The green line shows a typical solar production curve. And you can see there's a mismatch. The solar is producing all kinds of power in the middle of the day, and we don't need it. So what batteries do is allow you to capture that extra solar energy when it's not being consumed, and then discharge it in the afternoon, in the evening, when it is needed. And what utilities will do to try to manage these peaks is that they'll charge a premium for that afternoon and evening electricity. So this is called a time of use tariff, or TOU. So you can use an energy storage system to save all your free energy that was going to be wasted or sent back to the utility rate for pennies, and discharge your battery to meet your loads in the afternoon and evening, so you don't have to pay those expensive time of use rates. Okay, next slide. Now, in the title of the whole presentation today, we use the word microgrid. What is a microgrid? Well, the way we use it is it basically means both all the functions of grid connected systems that we just talked about, keeping your bill as low as possible. And when the grid quits, you have full backup power. So you have power, you keep your lights on. So this is the idea of a microgrid. It's like bringing the wilderness into the middle of the city. Next slide. Now, as we move into energy storage, a lot of this comes down to cost. These systems are expensive, there's no question. We know that they'll save money over time, but in many cases, the cost of the system will not be overcome with any single benefit of storage, right? So this is this whole idea of stacking. So with energy storage and solar and microgrid controls, we can increase self-consumption, we can reduce your demand charges, we can reduce your time of use rates. We're starting to see situations where the utility will, with your permission, ask to discharge your battery at certain times of the day to support the whole grid, and of course pay you for it. And if you have backup generators, you can offset your fuel consumption. But all of these things save a little bit of money, but together they save a lot of money. So the key to financing and making microgrids work is to identify as many benefits as you can, stacking those benefits with the same resource. Next slide. And then how much does a power outage cost? So I know talking to folks in Puerto Rico, you all are no stranger to power outages. So you know what this disruption is like. But you can see that a lot of times when people are running financial calculations for energy storage systems, they're really only capturing the stuff that we already discussed about demand charge reduction and time of use reduction. But every single power outage has a real cost. So this particular slide was created a few years ago, but it's just indicative how in the healthcare industry, for example, each power outage costs the equivalent of nearly $60,000. And that's in lost production, it's in running backup generators, it's having to reschedule your patients, like all that kind of stuff. And so you can see, you know, in the worst case, if you're a batch manufacturer making a thing and the grid quits in the middle of you making that thing, that's a huge loss. But even down into schools, every time it's a grid outage, it's like $5,000 of lost production, you know, loss of kids being sent home and, you know, all that stuff. So all it takes is just a few grid outages a year to have these microgrid systems pay for themselves in a hurry. Next slide. So one of the things that at Blue Planet Energy we've put together is a tool that helps calculate the impact of power outages. So we won't go into this now, but just say that we've taken efforts to characterize and quantify the cost of a power outage. And so we'll help plug that into the whole financial analysis of the system. Next slide. And many of you in Puerto Rico and other places say, okay, power outage, no big deal, I'll just get a generator. Well, generators don't save you money. They end up costing money every time you have to refuel it, every time you have to maintain it. And a generator installation does not cost very much less than a full microgrid installation. And you have to keep putting another 10 to 20 cents per kilowatt hour into it forever. And then, of course, we're all concerned about carbon. This graphic I find a little bit chilling. So that's 1 gallon of gasoline produces 19 pounds of CO2, which is a volume of the box you see there that's like bigger than 2 people. So don't just think that you're going to just do a generator for resiliency. Next slide. So how do we calculate the cost of this? Just in general, you take however much it costs to buy a thing and you divide it by the lifetime. So how long it lasts. So the reason why solar is so cheap is because it lasts a long, long time with almost no maintenance. So now solar is the cheapest form of electricity on the planet, neck and neck with wind, but both of those are renewables, not coal, not gas. Storage, same story. How many kilowatt hours are you going to move through it over its whole lifetime divided by however much it costs? And then there's incentives. So then this is what Gabby will talk to us about here, and I've got to wrap up so he can talk. Next slide. But the key thing is total cost of ownership is taking this idea that we just discussed and really putting hard numbers on it. So our battery CapEx, so that means, you know, the cost to buy it up front is on the high side in the industry. But when you divide that by the fact that you get 100% depth of discharge and you get to do that 8,000 times, then we're right in there, competitive or better than batteries that cost less, right? So you can buy some other battery at half of our cost, but they last half as long and they don't give you the full battery, then they actually cost more per kilowatt hour. So keep your eye on the long-term advantage. This term is total cost of ownership. Next slide. Okay, we're wrapping up, but I want to be clear. When you work with us, we're not just selling you a battery. So here is a typical microgrid. So we've got the grid, is that funny looking little, power line thing there that's coming into your building. We've got the battery, which is our cool, smart looking black enclosure, has its inverter. You got solar, their inverter, you got your generator, and then you have your loads. And then up in the upper left, we have the energy management system. So the brains that's driving the whole thing. Next slide. Blue Planet Energy, what we do is we provide this is with the LX system. We provide the enclosure, the batteries, and the inverter, and the energy management system. So that's the stuff that we'll bundle, and we know how all this stuff works together, and we give it to you. Next slide. And then with all of this other equipment, microgrids are complicated. We provide guidance for all of the rest of the system design and specification. We have worked with many different solar inverters. We've worked with many different generators. We manage that whole point of interconnection with the utility. So we don't just send you stuff in boxes and say, good luck. We are your smart friend during the whole process. Next slide. And then we come out and we commission the entire system. So even the things that we didn't sell you, like the solar inverters or the generator, at the end of the project, we come out, boots on the ground, turn everything on, program everything, and then we continue to give you access to continue to tweak and fine tune the performance of the microgrid over time. So this is one of the places where not only are we the best battery, but we really provide the greatest support in helping you identify whatever your problem is, developing the whole solution, getting it up and running, and keeping it running for decades. Next slide. And with that, thank you for your attention, and I will hand it back to Gabriel.
Gracias, Wes. Thank you for your presentation. Pues vamos a continuar y ahora pues les voy a enseñar varios proyectos que hemos trabajado aquí en Puerto Rico, en facilidades críticas, para que estén claros. Ya en Puerto Rico ya tenemos sobre 20 megavatios hora de instalaciones, y este primer proyecto que les quiero enseñar aquí, este es el Hospital de Culebra. Hace varias semanas atrás, la secretaria de Energía, Jennifer Granholm, estuvo por allá viendo el proyecto. Y este proyecto para nosotros es bien importante porque, como bien saben, después del huracán María, hace varios años, Culebra, que se nutre por un cable eléctrico desde Puerto Rico, Culebra es una isla parte de Puerto Rico, pues ese cable se partió. Así que la isla estuvo, estamos hablando sobre casi un año con generador, corriendo toda esa isla. Así que a través de sin fines de lucros, es importante también recalcar que las sin fines de lucro han apoyado mucho a Puerto Rico y han sido parte esencial, y veo que también hay varias sin fines de lucros aquí, apoyaron directamente, y aquí se instalaron 128 kilovatios hora de almacenamiento de Blue Ion. Esta es la 2.0, es el modelo anterior de la HI. ¿Ok? También ese microred se le instaló. Can you go back? Sorry. Yes. En esta facilidad también se instaló un generador eléctrico para este backup en el caso que no haya sol. ¿Okay? En el caso que no haya sol, el generador prende y el generador carga las baterías. ¿Okay? Una vez que las baterías están cargadas, se apaga el generador y sigue corriendo las facilidades. Hemos visto ya que estas facilidades, este sistema está funcionando, y de hecho en el huracán pasado que tuvimos hace unos meses, Fiona, estuvieron sin electricidad, y gracias a la microred pudieron dar este servicio a la comunidad. Así que you go next slide, please. Aquí yo les voy a enseñar este es un proyecto también súper importante con organización sin fines de lucro por los nuestros y los instaladores. Quiero reconocer a MES Corp y también a Ángel Sayas, que han sido dos instaladores que han apoyado en esta iniciativa. Y estos son comunidades aquí en Puerto Rico que no están conectados a la autoridad de agua. ¿Okay? O sea, que estas son comunidades que están en el campo, en el medio de la isla, la montaña, donde para tener acceso al agua tienen que hacer un pozo, ponen su contador, ponen un contador y hay un contador eléctrico con una bomba y así es que se nutren agua. Disculpen, la gente estaba lavando sus ropas y pues lamentablemente muchas personas fallecieron dado a eso. Pues las organizaciones sin fines de lucro aquí en Puerto Rico están apoyando y se están haciendo microredes en estas comunidades, donde se está instalando un sistema de energía renovable, se está instalando baterías inversor y un generador, en el caso, para ahí crear ya lo que se llama una microred. O sea, que en el caso que se vaya la energía, como ha pasado varias veces, sea por outages o por algún desastre natural, las comunidades van a seguir teniendo agua. Y de hecho, pudimos confirmar que después del huracán Fiona, las comunidades siguieron teniendo agua. Así que ahí podemos ver un ejemplo, otro ejemplo de otro tipo de proyectos que estamos haciendo aquí en Puerto Rico. De estos proyectos ya tenemos sobre 35 hechos ya y hay varios más que están en desarrollo. Next slide, please. Algo que quería comentar también del otro slide, importante es que estamos apoyando a las comunidades, dándole las baterías, el sistema, apoyándolo, pero las comunidades se insertan en el proyecto. O sea, que eso también es bien importante. O sea, que las comunidades sean parte del proyecto para que entiendan cómo es que funciona. Y en su momento, si tienen que darle mantenimiento, tienen que verificarlo, lo puedan entender. Este proyecto, este es un proyecto que se trabajó con la Cruz Roja. Esto también fue después del huracán, donde se hicieron más de 100 escuelas públicas, donde la Cruz Roja donó 2 microredes por escuela para darle energía, en el caso de una emergencia, darle energía a la cafetería. Y como ustedes bien saben, muchas de estas escuelas se usan como refugios cuando hay un desastre natural. Así que lo que queríamos hacer estos refugios resilientes, preparándolo a la cafetería con una microred, con sistema de energía renovable, baterías y un generador. Y también se le dio energía a varios salones en el caso de que hayan personas que necesiten conectar una máquina de salud, de respiratoria, o que quieran cargar su teléfono. En fin, preparar el sitio apto en el caso de que haya un desastre, que las personas puedan ir para allá y puedan estar allí, puedan continuar sus vidas. Así que vamos let's go to the next one, please. Ok, ahora vamos, después que ya hemos hablado de la tecnología, hemos hablado, Wes explicó muy bien las soluciones, pudo explicar bien los diferentes productos que nosotros tenemos. Vimos ya diferentes ejemplos de proyectos que ya se han hecho aquí en Puerto Rico. Pues ahora venimos con oportunidades de funding para estos proyectos. Y después del huracán, a través del Departamento de Vivienda, se han creado 2 programas, que el primer programa fue el de CDBG DR, que es Community Development Block Grant Disaster Recovery, que fueron los primeros fondos que se trajeron sobre 19 programas para poder impactar a esas comunidades que sufrieron durante el huracán o tuvieron pérdidas del huracán o comercios. Eso, de hecho, ahora mismo hay unos programas actualmente pasando para residencial, donde se le están poniendo un sistema solar, una cisterna a esas personas residencial que fueron afectados. Pues ahora viene otro fondo que es CDBG MIT, Community Development Block Grant, mitigación. En estos fondos estamos hablando de 8.9 billones de dólares en fondos. En CDBG-DR habían 20 billones, pero estos fondos en particular es para impactar, para prepararnos en el caso que venga un desastre natural, estemos preparados, ¿ok? Estemos resilientes. Y ahora mismo hay un programa dentro del CDBG MIT, hay un programa que se llama Infrastructure Mitigation Program. En ese programa hay 4.5 billones de dólares actualmente, y de ese programa hay 1 billón separado solamente para instituciones de salud, sean hospitales, sean laboratorios, en fin, cualquier institución que esté dando algún servicio de salud. ¿Okay? Importante recalcar que estos tipos de fondos que hay disponibles se pueden utilizar para poder hacer su propiedad resiliente o su facilidad resiliente, donde se puede instalar solar, baterías, se puede hasta añadir también un generador para crear esa microred. Actualmente, la fecha límite para poder solicitar estos fondos es marzo 31, y pusimos un enlace a mano izquierda donde pueden accesar, donde te dan las guías de cómo es que funcionan los fondos, quiénes son los elegibles, que podemos ver que los elegibles para estos fondos son el gobierno, organizaciones sin fines de lucros e instituciones de salud. ¿Okay? Así que hasta marzo 31 tienen para solicitar cualquier cosa. Nosotros estamos apoyando, entendemos muy bien el programa y los podemos apoyar a poder solicitar estos tipos de fondos. Next slide. Entonces, pues ya estamos casi terminando y quiero respetar el tiempo, pero vamos a dar ahora un resumen en general de lo que habló Wes, donde pues ya podemos ver que la solución que nosotros tenemos pues es una solución no tóxica, es segura, contamos con todas las certificaciones, contamos con una garantía de 15 años, 8,000 ciclos y se puede utilizar al 100%. Este tipo de producto se puede diseñar para satisfacer a cualquier necesidad del cliente. Integramos diferentes elementos de tecnología, como mencionó Wes, desde viento, generadores eléctricos, por supuesto solar, y también apoyamos en todo ese proceso desde el principio, desde que tienen un proyecto, desde que tienen una idea, hasta el final, desde ya encender el proyecto, apoyarlos a que esté todo funcionando y apoyar al instalador. Y por supuesto, pues tenemos una cultura, somos una empresa de Hawái, tenemos una cultura de Aloha, y de verdad que para nosotros es bien importante pues la gente y por supuesto el planeta. Yo creo que con eso termino. Next slide, please. Con eso termino. Ahora podemos, cualquier pregunta que puedan tener, por favor. Entiendo que, Wes, I think there's a question. I don't know if you answer, but right now, if there's any questions o hay alguna pregunta que quieran hacer con relación a la presentación, ahora es el momento, o también me pueden escribir y también podemos apoyarlo, cualquier cosa que después tengan una pregunta.
Yeah, there was a question about Enphase microinverters and also about VPP, virtual power plants. So I answered them both back to the person. But yeah, so Enphase, they're really excited to keep all Enphase projects using all Enphase gear. So they can be a little hard to work with. But with the HI, with the various inverters, they can AC couple Enphase inverters into our, into the microgrid. On the LX side, they're very hard to control. They won't share their communication protocol. So we try to steer people towards other inverter companies that are easier to work with. SMA, SolarEdge, Fronius, all those guys work great with the LX system.
Perfect, Wes. Thank you. No sé si tienen alguna otra pregunta. Ok, tenemos una pregunta aquí de Juan Palomares de Colombia. Entiendo cómo podemos cotizar sistemas de batería, necesitamos proyectos en Colombia. Actualmente, y de hecho, gracias por la pregunta, y actualmente tenemos en el chat Daniel Medina, que es nuestro colega, él está en Colombia. El correo electrónico yo te lo voy a dar, o si daniel@blueplanetenergy.com, te lo voy a dar ahora. Te puedes comunicar con él, y sí, actualmente tenemos proyectos en Colombia, y de hecho hemos trabajado con varias organizaciones allá, y tenemos proyectos también en Costa Rica, República Dominicana, El Salvador y México. Y de hecho quiero dar un saludito a los compañeros de México que también están por ahí. Let me see if there's any other questions. Información cooperativa, seguro, Wanda. Vamos a ver cómo podemos contactar mi condominio. Para condominios definitivamente se puede utilizar este sistema. Por supuesto, se puede utilizar para áreas comunes y para darle energía a los ascensores. Y de hecho, los ascensores tienen un pico bastante alto. Así que definitivamente este tipo de tecnología se va a poder utilizar para ese tipo de aplicación.
Hey, Gabby, there's a question on here for me to talk about.
Yes.
So Alexis says, would it be possible to create a microgrid between 3 or 4 homes without connecting them to a utility provider? Yeah, absolutely. So where usually where that becomes an issue is in the States, in most places, the utility won't let you do that, right? So they want to be in charge there. But in Puerto Rico, for the last, I don't know, maybe a year, they passed regulations that allowed just this exact, structure. And we're actually just starting a project. I can't go into details because of NDA and stuff, but it's a mix of a few homes and a few businesses, and they're all collectively going to be having solar and storage and sharing the resource back and forth. And then collectively, the whole group will have one point of connection to the utility. So Puerto Rico is actually leading the way in these kinds of structures. And if you have that kind of application, we encourage you to reach out to Gabby or me, and we'll help you figure out how to do it.
Thank you, Wes. Y de hecho, hay un proyecto en México que yo fui a visitar hace poco que están haciendo eso mismo. Están conglomerando varias casas y están haciendo su microred. Así que en Puerto Rico, que bueno, Ani, gracias por esa pregunta. ¿Quién da servicio? Nosotros en Puerto Rico, ahora mismo en Puerto Rico tenemos apoyo técnico. Alison Mason, que de hecho está aquí en el webinar, está en Puerto Rico y ella nos apoya para cualquier apoyo técnico. También hay un boricua en Dallas, Iván, que también de vez en cuando viene para acá y nos apoya. Sinceramente, este sistema, si se instala correctamente, no va a ser bien mínimo el apoyo técnico que va a necesitar y la garantía. Así que para nosotros es bien importante adiestrar y por eso usamos mucho adiestramiento a los instaladores y los apoyamos. O sea, que solamente, como menciona Wes, no solamente le damos una batería, le proveemos una batería, estamos con ustedes apoyándolos en el desarrollo del proyecto. Okay. I think there's another question for you, Wes, from Francisco Ruyan. The average load time.
I don't see it. Oh, there it is. Okay, the average load with the genset for the backup battery without solar or grid. Well, everything is designed for the application, so you can just put as many batteries as you want to last as long as you want. Do you understand? You know, we can go from 8 kilowatt hours of storage up to, you know, hundreds of kilowatt hours. So, you know, when you asked me about what the average is, I really don't have any idea. And the average doesn't really help us because it's like saying, what's the average shoe size? And if your foot is bigger or smaller than that, then the average doesn't help you very much. But yeah, reach out with any specific applications and we'll help puzzle out the best way to solve it.
Perfect. Jan, can you pass to next slide, please? Exactly. Ahí cualquier cosa que también es para apoyo y si les interesa ser partner o ser un instalador certificado de Blue Planet, nos pueden escribir aquí. Estamos para apoyarlos. Estamos en Latinoamérica y también en Estados Unidos, también en Asia. Así que cualquier cosa estamos a las órdenes. No sé si hay alguna otra pregunta. No sé si hay alguna otra pregunta, pero dale, next slide, please. Ahí está el correo electrónico mío, gabriel@blueplanetenergy.com, y el de Wes. Estamos aquí para apoyarlos y yo les agradezco un montón que han sacado de su tiempo para estar con nosotros un ratito. Cualquier cosa me pueden llamar directamente, también pueden comunicarse con Daniel en Colombia y nada, yo creo que estamos aquí para apoyarlos y para poderlos apoyar en todos estos tipos de proyectos. I think we're pretty, yes, I think we're. Pues yo les agradezco mucho por el tiempo. Mahalo. I don't know, Wes, you're gonna say last few words.
Just thanks to everybody for joining us today, and we look forward to helping you solve any of your problems that you have. We're excited to do this work, and we look forward to working with you.
Igual por acá, cualquier cosa estamos a las órdenes. Muchas gracias por la atención y que pasen un excelente día. Thank you.